Exercise 2, question number 1. So we want to sketch this one, and then part A we want to find y equal mod fx, and then part B is this is part B, and part C is y equal f mod x. So this is a quadratic equation. This is positive, it has a minimum. Then we can easily bracket this one, x minus 8 and x plus 1. So then the root is going to be x equal 8 and x equal minus 1. So this is minus 1 and this is 8. Part B, we want to apply mod value. We want to make all y is positive. So we want to get rid of this part, and then we want to bring a mirror here, and we want to draw the mirror reflection. So the graph is going to be something like this. So here, here, here. So this is y and x-axis. The graph is y equal mod fx. Now part C. Part C, what we have to do? We have to bring a mirror and we have to leave the mirror. Then we need the mirror reflection of this part, which is this one. So then if this is 8, this should be minus 8. This is 8, 0. Then by symmetry this should be minus 8, 0. X and Y. This value is when x equals 0, this is 0 and minus 8. So this is minus 0 minus 8. This is 0 minus 8 point. Question number 2. Gx equal cos x, and this is a domain given. We know cos graph always start when, okay, this is the range, minus 1 to plus 1. When it is 0, the cos graph start from here, 1. Sine graph is start from 0. So then 1, 2, 3, 4. 1, 2, 3, 4. So this is 90, 180, 270, 360. So this is negative. And so start from here and going through here and this one. And so this is dx equal to y equal cos x graph. Now we want to draw part B, gx equal mod cos x. So all the gx values, which is y values, we have to make positive. All negative y values we have to make positive. So we will bring a mirror and we'll keep it here. Then this is going to be this part, something like this. And also when we keep the mirror here, so this is going to be something like this. And this is +1 and -1, the range. So that graph is going to be 1, 2, 3, 4, 1, 2, 3, 4, and this is the y equal 1, and then so this is the graph. If you delete this side and then if you draw like this, then it's fine. So this is the graph. So I'll go back to the previous one, this one. Now we want to draw C gx equal cos mod x. So what we can do, so we have to delete this side, this curve, and then we want to bring a mirror and we want to keep like this. Then the mirror reflection of this part. But we know by symmetricity, it's going to be the same graph. 1, 2, 3, 4, and 1, 2, 3, 4 similar distance. And this part mirror reflection is this one. And this part is here. And this part mirror reflection is up to here. Question number 3. So this is the graph. This is all positives, x positive. So x equal minus infinity to y minus infinity. X go to positive infinity. Y go to positive infinity. If you can't remember how to sketch this graph, go year 1, chapter 4. You can check from year 1, chapter 4, my discussions that how to draw this kind of graph. And this is a cubic graph. And the root is x equal 1, x equal 2, and x equal -3 roots. When hx equal 0. So I'm expecting a graph like this. Minus infinity to go to minus infinity, and this is 1, 2, 3, 1, 2, 3. So this is -3. So it should be coming from this way. Minus infinity to minus infinity. Positive infinity to positive infinity here. So it should go like this. And 2 and 3. So this is 2, 3. So this is the graph. Now we need to draw part B. Hx equal y equal mod hx, or mod x minus 1, x minus 2 and x plus 3. So we can do that. We want to get rid of all negative y values. For that, we have to bring a mirror here and leave it here. Then the mirror reflection of this part. And okay, this is fine, all y's are positive. Then I can see here, this, if you look at the coordinate y value is negative. So from this point downward, so I'll bring the mirror here, and then mirror reflection is this way. The mirror reflection of this one is this. So I will delete this one. So this is y equal mod hx. Now I'll go back to the previous graph. Now I want to do y equal h mod x. For that, I'm going to do, I'll delete this part, then I'll bring a mirror and I'll leave it. Then the mirror reflection, it means this is 2, 1, 2, 2, and this is 3. So this part is going to be like this, and up to here like this, and this is the other one. Question number 4. We want to sketch this one, a over x square. We can remember y equal 1 over x square is this type of graph, and then y equal a over x square, a greater than 0. Then it also a graph like this, but according to this a value, the graph is expanding, and x is an element of real numbers. X can't be 0 because x equals 0 is asymptote. So x equals 0 mean y-axis is a asymptotic. Now question 1. So okay, this is the sketch. And explain why it's not necessary to sketch y equal mod kx and y equal k mod x. Now from this one, what are we doing is we turn all negative y value to positive. So when you look at this graph, there is no negative y values. There is no graph here. It means there is no negative y values. So there is nothing to turn. So this graph is same as this one. So y equal kx also same. Y equal kx mod also same. There are no negatives. Another thing is, now mod x, k mod x. How do we do this graph? We delete this side and we'll bring the mirror reflection and we draw of the mirror image of this one. And we know that the mirror image also same as graph. It is overlap on this one. So because of that, they all same. The same graph. Now part C, we want to draw when a less than 0, a greater than 0, then the graph is going to be something like this. And because a is negative, because of that all the values, all the y values we are turning into negative. K mean y value. So all the y values we are turning into negative because a is negative. So this is y equal mx graph. Then part D, the question is we want to check whether this is true or false. Mod kx. So mod kx, this graph is equal to mx. I don't put mod. It is clear that this one and this one is not equal because this is mx. What will happen? Mod value. When we put mod y equal mod mx, what is the task? We want to turn all the negative values, negative y to positive. So it means this graph is going to be like this and this one is going to be like this. So then this is y equal mod mx. So the mod mx and mod kx both are same. It means this is true. So this is the graph I draw again. And the second one we want to check k mod x whether it is equal to m mod x. This is so. So this is k mod x as it is. And what is m mod x? So what this is y equal mx. So how do we draw y equal m mod x? So we draw m mod x. We delete the side, the graph, and we'll bring a mirror and then mirror reflection. Mirror reflection also going to be same as graph. So now this one and this one is similar? No. So this is false. So this is false. I draw this one again as it is. And now we want to check the third one. Mx equal m mod x. So this is mx. So how do we do m mod x? So m mod x also is going to be same. So we delete this one and we'll bring a mirror and we did already and mirror reflection of this one. So this is same as mx. So this is true. Question number 5. One point is here, one major point, another point is here, and other point is bit lower. So it should go like this. And so this is y equal px graph. And now we need to do y equal mod px. So we want to get rid of all negative y values. So for that I have to identify the negative area. So this is the negative area y values, and I can see this part of the graph. So I want to make this y values negative, positive. So for example, this point -4 -5, so then it has to be -4 +5. So -4, this same length, same length. So -4 +5. So instead of doing taking all point one by one, the simple method is bring a mirror and keep the mirror, and then mirror reflection of this part is something like this. So this is the mod px graph. Now I want to draw y equal p mod x. Then I don't bother the graph on left side, and I'm going to bring a mirror, and I want to leave it on y-axis, and I want to get the mirror reflection. So this is 3 0 3 0, this is 2, then this is to be minus minus 2, this, so this height is 1, so this is -2 1. So this is the mirror reflection, this is the mirror reflection of this graph, which is y equal p mod x.